guys, before I do that, your thingy is due tonight. What am I saying? Yes, that. Your progress check is due tonight. So if you haven't done it yet, you need to do it, okay? It's just spinning. It's just spinning. Let me tell you who hasn't done it in this class. Oh my gosh. Where am I? Oh my gosh, what a mess. There it is. Okay. So in this class, there's a lot. Okay. In this class, these are the people that have not done it yet. Austin, Riley, Daniel V, Raja, Daniel T, Juan, May, Lily, Sam, Jonathan, Jaden, Ryan, and that's it. So those are a lot of people. Guys, 10 homework points that you have huge control over, okay? Due by 11:45 tonight. I've given you lots of time. Don't get a 0 on that. Come on. 10 points. All right. So don't forget, Monday I will not be here. You will have a sub. All you're doing is working on finishing the 3 homeworks from this week if you didn't, which you might not have. Remember, notes have taken a little longer these days. Today is a shortened class because of the pep rally. I'm going to get you all the way through to I'm going to actually start the homework with you, and we'll see how much more time you have after that. But remember, Monday there's nothing. There's no homework check. There's nothing open in College Board that you would need to work on. Nothing. So all you have to do on Monday is catch up, finish, maybe watch some videos if you want to get some deeper understanding. Go back over any of my videos, notes, homework, okay? Ask each other for help. You guys are good about that. We already talked about that. But that's Monday, okay? When I come back Tuesday, we'll finish this. What we're doing today, though, is getting closer to the unit circle. In fact, I'm going to start introducing it today, and we'll finish it on next Tuesday. We are zooming into the 3 most important trigonometric functions, sine, cosine, and tangent. Even though we don't even mention these today, we will on Tuesday. You're learning about sine and cosine today. You just don't know it really yet. So we'll make that connection next week. But some really, really basic building blocks today. Some super, 100 supers important, easy, basic, fundamental parts of trig that we need to know, and we're just going to build on them. So you want to have a good foundation. So when I give you harder stuff, you're not like, wait, but I forgot how to do that or whatever, okay? So what do engineers, artists, airline pilots, carpenters, and golfers have in common? They all work with angles like we all do from time to time. There are times we can estimate an angle, like a golfer on his tee shot, but a carpenter or engineer must measure angles precisely in order to be successful. Our chapter begins the journey into trig with an introduction into angles and their measures. In this lesson, we will examine properties of angles and their measures. So let's talk about this first one. Standard position is an angle whose vertex is at the origin of a coordinate system and one ray is on the positive axis. Okay, so here's an angle that's in standard position. The vertex of an angle is like the point in the middle. That is always at 0, 0. And one of the rays, that's a ray. A ray, remember, is just has an end point at one side and an arrow on the other. So an angle is 2 rays that meet at a vertex. The one of the rays is on the positive x-axis. This is called the initial side. And it doesn't move. It's fixed. It stays right there. Never moves. We start here, and then this ray, called the terminal side, is the one that moves. So let me say that again. We always start on the positive x-axis. The initial side is always there. It'll never be somewhere else. It'll never move. And then we have a terminal side that does move. In other words, picture this. This is your initial side, and this is the terminal side. They both start at 0, 0. Guys, please stop talking. The initial side stays right where it is, and then the terminal side creates the angle, and it moves. And it can move counterclockwise, like I'm doing right now, or it can move clockwise, like I'm doing right here. But this one never moves, okay? Jaden, head up. And New word for a lot of you, theta. Theta is a Greek letter. The Greek letter looks like a circle with a little squiggle in it. I've also seen it with like a straight line. I've also seen where the line doesn't connect. Understand, it doesn't really matter. I always write it with a little squiggle because it's cute. But theta is a Greek letter, which means it's a variable. Like we use X, and we'll use X and Y just like we always do out of the English alphabet. But theta is a Greek letter that represents something called angle measure. And the reason you're going to start seeing a lot of Greek symbols and letters, we use a lot of their alphabet, alpha, beta, gamma, kappa, sigma, their alphabet for variables is because the Greeks are the ones that developed this branch of math called trigonometry, so we honor them by using a lot of their variables, okay? So just understand, this is nothing to be scared of. It represents, it's like x equals 5. X is telling you that's the answer. That's what x is. Theta equals 25 degrees just means that's your angle measure. That's the answer, okay? So you're going to hear theta a lot. The Greeks say theta. The rest of us say theta. So if you ever hear somebody say theta, they're probably Greek. I had a student from Greece last year who said that, okay? So that's standard position, initial side, terminal side. We'll talk about coterminals, angles in a minute, but let's talk about the most important part of our life, unit circle. This is life. This is everything, okay? Listen to what I'm going to tell you right now. I'm going to introduce the unit circle to you with the most basic parts of it, and it's so simple that students overthink it. So pay attention. The unit circle is a circle whose radius is 1 and its center is at the origin of the coordinate plane. Points on a unit circle are related to periodic functions, which we'll get more into another time. So here is a circle, and it's called a unit circle, where this is the origin of 0, 0. This horizontal line is called the x-axis. Imagine that. What do you think this one's called? Y-axis. Okay. If I took this and actually drew it on graph paper, you don't need to do this, just watch. Here's what the unit circle looks like. Ready? Here's my y-axis. Here's my x-axis for the circle. That's the unit circle. That's what everybody's so afraid of, okay? It's a circle with radius of 1 from the center to any point. That radius, the whole way around, is 1. That just gets blown up to look like this, so we can fit all this stuff, because all this stuff is going on in that little bitty circle, okay? So, but at its core, it's just a circle with a radius of 1. So if I asked you guys, which you all know how, all of you know your way around the coordinate plane. If I gave you a piece of graph paper and had you plot points, or here's some points, what are the the coordinates, you'd all get 100% on it. We know where positives and negatives are. We go left or right, up or down. All of you know that. So having said that, I'm going to tell you what the first 4 points are. In a second, I'm going to write them here, and in a minute, I'm going to write them on here. So if you want to start writing them in here, this is this. But if I ask you, what is this point right here? What is it? Yeah, guys, it's just, if I ask you what this point is, what is it? That's 1, 0, okay? All I did was, cut off all the rest of it. This point right here is 1, 0, right? You go to the right 1, up or down 0. Well, that makes this point what? Right here. -1, 0, right? It's just a point. What's this one? 0, 1. And this one is 0, -1. You just learned the first 4 points of the unit circle. Here's the problem. If I had to say what the majority of my students make mistakes on anything that has to do with trig, it's those 4 points. Not the craziness in between, because there's a whole bunch of other ordered pairs on here. But look at this pink paper I have. Look at these 4 points. I call these corners, 4 corners. They're not corners, it's a circle, but it makes sense to say the 4 corners. There's that 1, 0, -1, 0, 0, 1, 0, -1. It's blown up. So for some reason, people get confused. That's not really what they get confused about. When students mess up on these four coordinates, it's because they mix up zeros and ones and negatives. You know why? They try to memorize. And they're just too close together, and we just kind of memorize, and we mess up our memorization. Remember I told you, we're not memorizing. We're understanding it. That way, a year from now, when someone asks you, what is this point? You're like, oh, that's 0, 0. So it's in your brain. It makes sense. It has a connection to knowledge you already have. Okay? So just always think of the unit circle as those 4 points that are just here, 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 and here. Don't let it throw you off that I chopped off all of this and I made it like this. Or that I took this little tiny circle and blew it up to a big picture. This is still 1, 1, 1, and 1. You guys get what I'm saying? It's not hard. It's connected to knowledge you already have. All right? Let's keep going. The unit circle, when we do anything on the unit circle, okay, unit circle is always counterclockwise. Okay, and I'm going to explain that more as we go, but maybe write it right there. So let's talk about coterminal angles. Coterminal angles are 2 angles in standard position that have the same terminal side. Okay, so co-pilots, co-captains share the job, right? Share the piloting, share the captaining. Co-terminals share a spot on the unit circle. They hang out at the same spot, but they have different angle measures, and I'm going to explain that right here. So before I do that, let's just kind of talk about a circle, okay? So here's the X and Y axis. Most of the time, we don't draw the circle around it because it just gets too busy. But you can imagine please, that there is a circle around it just like you see here, where this is 1, -1, 1, -1, okay? So if I start right here, remember I said this is your initial side and it's fixed. It never moves. That's called 0 degrees. 0, before you've gone anywhere. Remember, they're both right there. My initial and my terminal are right there at 0. They haven't done anything. They haven't moved. Well, if I go a full revolution around the whole unit circle and land where I started, periodic, what would that be? 360, right? Circles are 360 degrees. Jade, come on, I need you to be paying attention. You just learned your first coterminal angles. They are different measurements, but they share the same spot on the unit circle. 0 and 360 are coterminal. Share the same spot. Different numbers. Coterminal angles go on for eternity in both directions. Because all I have to do is go around the circle again, add another 360 and get whatever. And again, you can go around a circle as many times as you want, clockwise or counterclockwise. So you can get negative angles if you go the other way, okay? So let's continue with breaking down this circle. So, guys, your coordinate plane is broken into fourths. We're going to break 360 into fourths. In other words, if this is 0, what would this be? It's a right angle. What does a right angle equal? 90. And if I say, oh, if this is 90, well, this is 90. So 90 plus 90 is 180. So if you start at 0 and end over here, that's a straight line. Lines are 180 degrees. And we're just breaking into 90s. 0, 90, add another 90, add another 90, add another 90, gets you back to 360. Again, why would we memorize that? We should be able to do the math. I'm just breaking 360 into fourths. This one's easy because it's a 90-degree angle, right? It's a right angle. So this is 90. And then you go, oh, yeah, that's just 90. If I forgot this one, I can do some simple math. 90 plus 90 is 180. Oh, I always forget this one. Oh, I can just add 90 to that, and that gets me this one. Oh, and then I'm back to the beginning, which is a full revolution. Not memorization, simple math, okay? So let's look at our first example here. Draw theta is 220 degrees and label theta prime as the angle that is coterminal. Okay, so the angle that's coterminal, how about an angle that's coterminal? Because it's an endless number of them. We could add 360 or subtract 360. We'll just find one. So first of all, where is 220? Well, I don't know. She didn't talk about that. She only gave us these. We're going to estimate. 220 would be, remember, this is still quadrant 1, 2, 3, 4. What quadrant would 220 be in? 3. It's between 180 and 270, right? 220 is between 180 and 270. Guys, I need you to have your heads up. Daniel, come on. I don't want to have to keep stopping and tell you guys to put your head up. You've got to pay attention. Fake it if you have to. You cannot sleep in this class. I'm not going to allow it. This is 220, and you would show it. And by the way, you notice I didn't get a ruler out and measure this and break it down to where it is. It's somewhere in that quadrant. Perfect guess. We labeled as 220. I showed what direction it, W-R-A-P, that's called wrapping. It wrapped counterclockwise, which means it's positive, 220. That's it. That's theta of 220. Let's find a coterminal angle. Anytime you are asked to find a coterminal angle, which is going to be a lot, there's only one number you would add or subtract, and that's 360. Never 180, never 90, never 70, never anything else. 360. Because what we want to say is, who else shares this spot with him? Who else has that spot? Well, to get on to this angle, you would have to travel around again a total of 1 revolution, which is 360. If I go this direction, which is counterclockwise, I'm adding 360. If I go the other way, I'm subtracting. It doesn't matter. It didn't tell us any parameters about it. Let's just find one. So, for example, theta prime would be where we are right now. Let's add 360 degrees to it. Let's go 1 revolution around. Well, I put that in my calculator, and I got 580 degrees. So that means 580 and 220 share this spot. Not the only ones. It's a very busy spot. There's eternity, both directions, plus or minus 360, forever and ever, never find all the coterminal angles. Okay? But how would I draw that? Remember how I showed the wrapping? Let me do green because it's a little bit different color. So I started here, right? And I went all the way around 1 time. That was 360. And then I kept going and landed right here. So I went 360 plus 220, which gave me the 580. So you can see I could have done that. I could go again. And then I could go the other direction and subtract 360. So to find theta prime, which is just another way of saying, like, this one's x, this one's y, just another way of naming it, you're taking your angle, whatever angle they want you to do, and you're either adding or subtracting 360 n number of times. I just did 1. And the one I just did, n was 1. I just went around the unit circle 1 time. But you could have n be a positive or a negative number, any n value, just like yesterday when we did nz. Okay? All right, let's go to the next page. Let me start with C. We already talked about this. 1 full rotation is 360 degrees. So what would a quarter be? 90. Half would be 180, and then there's that other number of 270. Some really common, important numbers that you'll see a lot. So let's go back up and do A and B. So what they're asking here is, what is theta? Find the measure of the angle. So we want to know what theta is. So in this picture, the way you would read this is always starts here. Remember, we don't start anywhere else, but you can see it started here, and it ended here. So it's just from here to here. What is that angle measure? So use simple math. From here to just here would have been 90 degrees, right? That's 90. Plus, we went into the second quadrant. How much is this right here? What is it? Yeah. 45 plus 45 is 90. So half of 90 is 45. So they're saying this right here was 45 degrees. So that means this is 45. So 90 plus 45 is 135. So that's the measure of that angle. Okay? Look at this one. Notice we're wrapping in clockwise. That means I'm going to have a negative answer. The math doesn't change though, guys. If I go from here to here, how much is that? Just to there. 90, right? From here to here, that's still a right angle. It's just going the other direction. So that's 90 degrees plus, they labeled this as 30. So that's 120. But since we're going in the other direction, our answer would be negative. But it's the same math. It's a quarter of a circle plus a little bit more. Okay? So if you wrap clockwise, you have a negative theta. Counterclockwise, you have a positive theta. The unit circle is all positive angles. Unit circle is everything is positive. Okay? All right, next page. I'm going to go through this vocab very quickly because it's not super important. I would love to skip it, but I'll be a good teacher and not skip it. Central angle, an angle whose vertex is at the center of the circle. That's what we've been talking about. The vertex is at the center, origin 0, 0. All of the angles we deal with are central angles, fine. What is an intercepted arc? The portion of a circle whose endpoints are on the sides of a central angle of the circle and whose remaining points line the interior. Let me show it to you in the picture. We have an angle here. Here is the arc that's intercepted. So that little segment right here is called the intercepted arc. Why is that important? Well, there is a formula involved with intercepted arcs and radiuses, which is radii plural, and that's written here. And I'm going to read it, but it's not super important. What's important is that we understand what a radian is. So let me read it to you, and then I'll explain it in English. A radian is, 1 radian is the measure of a central angle of a circle that intercepts an arc equal in length to a radius of the circle. You can use a proportion to convert an angle measure from 1 unit of measure, okay, blah, blah, blah. Let me tell you what a radian is, okay? If I had Evan stand up and I measured his height with, in inches, okay, I get 1 number. Well, couldn't I also measure him in centimeters or any other angle or measurement? It doesn't change his height. It's just 2 different ways of doing it. How about the other day when we did, we had 4 hours, we had to change it to seconds. It was 240 seconds. 4 hours is 240 seconds. 2 different ways of measuring it, but it's still the same amount of time, right? Just a different way of looking at it. That's what radians are, okay? We've been talking so far about thetas in degrees. Well, there's another way to get angle measured, and that's radians. It's actually more common than degrees. In fact, your graphing calculators, you don't know it yet, I'll show it to you one day, when you clear your RAM, it defaults to radians. You're always in radian mode in your calculator, which is what you want to be in 99% of the time. We use radians more in calculus than we do degrees. Okay? It's important to know degrees because in word problems, we don't talk about radians. We use degrees. But when we work with trig, it's all radians. So we're going to talk about that next. Now so don't worry about the formula where it comes up to. I'm going to show you how to go from degrees to radians and radians to 2 degrees. It's a really simple formula. And at first you're going to be like, how am I ever going to remember this? Here's the formula. You multiply by pi over 180 or 180 over pi. And that's what I mean. It's like, I would look at that at first glance and be like, I'm always going to get those confused. I'm never going to remember which one is which. I'm going to tell you how to do it really simply. Don't worry. Super easy formula, right? Just 2 numbers in both of them. But this is a way, if I give you degrees and you need your answer in radians, or if I give you radians, you need your answer in degrees, an easy way to convert, like minutes to seconds and all that stuff, okay? And these are what I call freebies on a test. These are the easiest ones, okay? And most of your homework are these, all right? So let me show you what I mean. Find the radians for a 60-degree angle. So I have 60 degrees, and I want to change it to radians. So we just learned this formula. If we want to go from degrees to radians, we would multiply this by pi over 180. Now, radians are almost always in terms of pi. Go back to geometry, and remember, sometimes your teacher would say, leave your answer in terms of pi or round to a certain number. Leaving an answer in terms of pi means pi just tags along. You don't put pi in the calculator. It's like an x. It just travels along. It's part of the answer. So really, all I have to deal with is the 60 over 180. So technically, I'm multiplying these straight across, although I'll show you on the next one. You can skip this step. But that's basically where we are. And then you have to simplify the fraction. How do you simplify a fraction on these calculators? 60 divided by 180, and then math, enter, enter. So that would be 1, remember the pi is still there, 1 pi over 3. And we would write that one more special way. Oh, well, let me just say this. This is fine. You could absolutely leave an answer like that. There's nothing wrong with it, but it's kind of like leaving a 1 in front of an X. We don't put it there. It feels weird. That would actually be pi over 3. So if there's a 1 on top, it's understood to be in front of that pi, just like with an X. So 60 degrees is the same as pi over 3. Okay? Let's do another one. 85 degrees. So degrees to radians. Now, as I just told you, you want, when you multiply, when you see an answer in radians, pi is going to be in the numerator. It always is. You're going to have a whole bunch of angles all over the unit circle measured in radians. Notice, if you just look at these, pi is in the numerator of every single one. You'll never see a pi in the denominator of a radian. That's going to help you remember, I want my answer in radians, pi needs to be on top. That's one way of knowing, oh, that's how I'm going to remember, pi always goes on top. Pi in the denominator, you'd look at your answer and be like, wait, that doesn't look right. So you'd be able to go back and do the other one. Okay? So again, remember I said you could skip that step. You can show more work if you want. But really, you know if I go to the next step, it's going to be 85 over 180. You don't have to write it. Just put it in your calculator. 85 divided by 180. Math, enter, enter. Gets me 17. Don't forget there is a pi there that's just kind of hanging out over 36. 17 pi over 36. Okay? It's simplifying a fraction. Now, remember I said 99% of the time radians has pi in the answer? It does, in the numerator. But sometimes it's given to you as a decimal, but it'll tell you this is radians. So here I'm going from radians to degrees. This is just not written in terms of pi. It was rounded to 2.5. Okay? So just like I could have made this one rounded by including the pi in there, by multiplying by pi. This is 1.48 blah, blah, blah is the same as 17 pi over 36. This is an exact answer. That would have been rounded. So that's why we mostly keep radians in terms of pi. Pi will be the answer. Once in a while we'll see it like this. No big deal. Radians 2 degrees. That's 2.5 times 180 over pi. And I'm just going to put that in my calculator. 2.5 times 180 gets me 450. And I don't have to write this step. I could have just gone right to now divide by pi. But that's what I have. And then I'm just going to divide by pi. Guys, anytime we have to use pi and we're using a calculator, use your pi button. It's right above the radical. Why? Because your calculator has all of the digits of pi stored in it. And if you use pi, you're just going to round it at 3.14. Your answer would be inexact. So divided by pi equals approximately 1.43.239. We're going to degrees. Make sure you put a degree symbol. Okay? So we'll practice those in our homework together in a minute. We're almost done. Stay with me. Last page. We talked at the very beginning of class about degrees. Now we're kind of into radians. Remember I gave you the 4 corners of degrees. Let's do the same thing right here with radians. So we always start here. Remember it was 0 degrees? Well, now it's 0 pi. Because we're in radians, all of our angles are in terms of pi. Now listen, if I start here and I go all the way around the unit circle and come back, that would be 2 pi. So 0 and 2 pi are coterminal. So 360 is the same as 2 pi. 360 is the same as 2 pi. Let's break it down from there. So simple math, not memorization. If the whole thing is 2 pi, what would half of it be? 1 pi, right? So pi and 180 are the same, right? The whole thing is 1/2 plus 1/2 of the circle is 2 pi. 1/2 is just 1 pi. Well, okay, what's in the middle of 0 and 1? It'd be half, right? So half of pi. That's 1/2 pi, or pi over 2. Now you see, okay, if you break 2 divided by 4, we get 1/2, 1. This would be 1 1/2, which is 3 halves, okay? 1.5 is 3/2. So we would do 3 pi over 2. And then another half would be 2 pi. So those are your 4 corners. It's math. It's not memorization. Maybe this is memorization, 2 pi. The rest of it, you should be able to find it mathematically if you forget. Okay? So let's sketch some. This is real quick. Now, if this is 0 and this is 1/2, what's in between 0 and 1/2? I like to think of pi as $1. This is $1 right here. Okay, $0 and $1. So half of $1, right? 2 quarters. So what would be right here is 1/4, right? So that's pi over 4. So you have 0 quarters, 1 quarter, 2 quarters, which is 1/2, half of $1, and then this would be 3 quarters. It's math. So pi over 4 would be wrapping the other direction, and it would be right here. So that would be negative pi over 4. Whereas positive pi over 4 would have been here, right? It's just wrapping in the other direction. It's the same distance from your initial side, but it's just the other direction. Pi over 2, right, would be up here. Show your wrapping. And pi would be like that, okay? Very last thing I have to tell you, and then we'll do one in the homework together. Remember, again, everything we do, we have some talk about degrees, we have some talk about radians. So we have to have coterminal, a way of finding coterminal angles for radians as well. Remember, for degrees, I told you, anytime you hear coterminal and we're working with degrees, you think 360. What do you think we're going to think about for radians? What's equal to 360? What is it? 2 pi. So anytime we have to do a full revolution with degrees, we use 360. A full revolution with radians is 2 pi. Same exact situation as we did here, but you're using 2 pi instead. And we'll do one in the homework here in a second. Okay? All right. That is the end of the notes. I am going to start the homework with you and do some, and I already changed it from what's on the board. So fix that. Write that down. Keep it fast. We can get to the homework. And I'm going to do those with you. All right, starting with number 1. Let's sketch that angle. Okay. 3 pi over 4. So, I know I just went over it. You know this is pi, and this is less than 1, right? This is 1 pi. We don't put the 1 in front of it, but that's 1 pi. This is less than a pi, so you know it's going to be in quadrant 2. And I'll just tell you now, all of your denominators of 4 are right in the middle of a quadrant. It's a quarter, 3/4. Okay? That's it for that one. Here's where I didn't get to do any with you. 5 and 7. Find a measure. So this is coterminal. Find a measure of an angle. Now they're giving us a very specific part of the unit of a circle they want us to be on. You see coterminal. The minute you see coterminal, you say, oh, is it degrees? No, it's radians. So I'm going to be working with 2 pi. Nothing else. 2 pi is it. So what they want, though, is for us to be on the unit circle. The whole reason we have coterminal, I'm going to tell you, is sometimes they give us angles that are not on the unit circle. At a first glance, we know that's not on the unit circle because it's negative, by the way. If it's not on the unit circle, we use this skill to get back on the unit circle. You'll hear me say that all the time. Get back on the unit circle. Oh, she means add or subtract 2 pi. So I'm either going to add or subtract 2 pi to this. Which one is going to give me a positive answer? By adding a number to this or subtracting? Crickets. We'll do both then. So if I have negative 5 pi over 4, I'm either going to subtract 2 pi or I'm going to add 2 pi. Only one of them can be an answer that's going to give me a positive. So which one of these gets me a positive answer? So you don't have to know ahead of time, just like no one answered me right there. You just try it both ways until you see which one gets that for you. So how you put this in our calculator is ignore the pi. It's like adding numbers that have x's next to them. We don't put x's in our calculator. We would just put in parentheses, -5 divided by 4 minus 2. No pi's. And then math, enter, enter. Okay, there's one terminal. Oops, 13 pi over 4. But it's negative. I don't want that one. Got to be the adding. Parentheses, -5/4 plus 2. Math, enter, enter. Okay, that's positive 3 pi over 4. That's the one I want. That answer is between 0 and 2 pi. So let's sketch it. We always start here. We already talked about where 3 pi over 4 would be. It would be right there. Notice the way I showed my wrapping is showing that we're going in positive direction. What they gave us, by the way, was going this way, but ending at the same place. Remember, these are coterminal. Coterminal means they share the same spot on the unit circle. Okay? So the red is what was given. We fixed it. So am I going to add 2 pi or subtract 2 pi on this one? If you don't know, try them both. One of them's right. It's either add or subtract. It can't be anything else. So -11/15 plus 2. Math, enter, enter. 19 over 15 pi. Where the heck is that? Well, let's just make a good guess. If this is pi, that's 1 pi, right? This is greater than 1. It's an improper fraction. So I'm going to make an educated guess that it's probably in this quadrant. Could it be over here? Maybe, but I don't think it is. So this is just getting us started. Which is coterminal with -11 pi over 15, which would have been going in this direction, because it was negative. Okay? So we'll be practicing more of those next week. Finally, on to the freebies. So here's where you have to decide. No, don't go back and look at your notes. I'm going from degrees to radians. This is where I said some people could get confused. Wait, is 180 on top or on bottom? If I'm going from degrees to radians, don't forget, you want pi on top in your answer. So I'm going to use the formula that has pi on top. That's it. Easy way to remember it. So this is 420 divided by 180. Math, enter, enter. 7 pi over 3. If I did it the other way, the pi would be in the denominator, and it would look funny to you, and you'd be like, oh, I did the wrong one. Let me go flip it. Okay? So that's what you're doing for the next few. The bell rings at 9:42, which is about 2 or 3 minutes away. Remember, Monday is a work day. Don't forget to do your progress check. If you want to go get your phone right now to remind yourself, put a reminder in, do something, ask your friend, your girlfriend, your boyfriend, somebody to remind you. What? Nope, it's due today at 11:45. Oh, no. Well, maybe she didn't submit it. I don't remember who I said, but I can look again. It's making me verify my email, so it's sending me a code, blah, blah, blah. I said, oh, it was that Sam. Sam Salone. Sorry, it's you that hasn't done the progress. You know what I'm talking about, Sam? Okay. Yeah. I forgot there were two. Now that I remember that. But. Oh, fun. You're going to feel so good the rest of the day, though.
Yeah, but I have like, it's going to go to a soccer game tonight. So So
Just to watch. Yeah.
and it's at like Mitchell, so it's like decently far away.
Right.
But I could be up at like 5, 10, I'm gonna be dead.
Yes, you are. Yeah, you are. Don't forget your progress check. Have a good weekend, guys. I'll see you Tuesday.